Here at the Tapco Group, we believe our way of doing things is genuinely better. This is why we created this sales pitch training video to demonstrate why Foundry is truly a best-in-class product using facts and data. Foundry has the most realistic surface texture in the industry. Look at the two textures. It's very difficult to tell which one is natural cedar and which one is Foundry. This is because natural cedar was used to cast the wood grains for Foundry shake and shingle. Foundry's surface texture is identical to genuine cedar. The reason Foundry looks so authentic is because it has at least 72 unique wood grains per profile. Each panel has at least 9 shingles. Each profile has 8 unique panels. Our competition has only 1 or 2 unique panels. This is why Foundry sets itself apart from the competition on an installed application. All materials move when subjected to a temperature change. This phenomenon is described by the coefficient of thermal expansion. Foundry's material properties were designed to have low thermal expansion. When calculating the change in length of a material, 3 factors are important: initial length, temperature change, and coefficient of thermal expansion. These factors all contribute to the change in length of a panel due to thermal expansion. Foundry's thermal expansion coefficient is significantly less than polypropylene's. But what does that mean in the real world? For a 60-inch panel that is subjected to a 65-degree temperature change, Foundry will expand by 0.125 inches, whereas polypropylene will expand by 0.207 inches. Polypropylene panels have 1.5 times the movement of Foundry. The nail slot is designed to accommodate the maximum amount of expansion and contraction a panel will be exposed to. Due to thermal expansion, we expect Foundry to expand or contract by 1/8 of an inch. The nail slot is 3/8 of an inch, and a typical fastener shank is 1/8 of an inch. This leaves 1/8 of an inch on either side for expansion and contraction. Foundry's nail slot is optimized for our panel size and material properties. Foundry's molded keyway widths are designed to hide lap joints. The lap joints will range from 1/8 of an inch to 3/8 of an inch due to expansion and contraction. Foundry's molded keyways cover this range. This prevents visual differences between the lap joint keyways and the molded keyways. Many polypropylene panels have narrow molded keyway widths. This only looks good out of the box. Once there is a decrease in temperature and the panel contracts, these laps become very noticeable. Material properties plus the single-course design allow Foundry to have the best installed aesthetics. Notice how the double-course polypropylene siding has very noticeable seams. It's almost impossible to detect Foundry seams. Thermal expansion, nail slot design, and molded keyway widths are the design elements that give Foundry the best installed look. All of these elements control the keyway widths at the seam. The number of courses molded into the panel also has a significant impact on seam visibility. Foundry's single-course design shows one seam, staggering no less than 6 inches from panel to panel. The spacing is different for every course. Double-course panels have one seam over 2 courses, spaced roughly 2 inches apart, but exactly the same from panel to panel. This means every other course, as you move up the wall, has identical lap spacing. This pattern in the keyways draws attention to individual panels. Single-course design plus controlling the keyway width at the lap all contribute to the most natural installed look, where individual panels cannot be identified. Foundry's single-course design allows for half the scrap of a double-course panel regardless of the roof pitch in a gable. 4 triangles need to be removed when cutting a double-course panel to a gable. Foundry's single-course design can be offset, and regardless of the gable pitch, only 2 triangles need to be removed. Single-course Foundry has half the scrap as a double-course panel in the gable. On a standard wall, Foundry has essentially 0 scrap, as long as the trimmed section has at least 6 inches and has the factory end tab. It can be reused. When a panel is trimmed at the end of a wall, the trimmed section, in this case trim A, can be used to start the second course. Continue to install full panels until you get to the end of the wall again. The last panel will be trimmed. In this case, trim B will be used to start the next course. This can be repeated for the entire wall, resulting in essentially 0 scrap. Foundry has a continuous nail hem and lock. This allows for Foundry to be installed just like typical vinyl siding. First, the butt edge of the top course should be aligned with the top lock of the bottom course. Press upwards to engage the lock. You will feel a snap when the lock is fully engaged. Foundry has an additional self-leveling feature. When installed, the butt edge of the top panel should rest on the panel below. Foundry's lock design does not require chalk lines, engagement tabs, center pinning, or temperature gauges, allowing for the easiest installation. Competitor products require a transition piece. Foundry's continuous nail hem locks directly into typical vinyl siding. A zip tool can be used on Foundry because of the continuous nail hem. If a competitor product is installed incorrectly or damaged, the entire wall must be removed to replace the panel. Again, Foundry has the easiest installation. Foundry was designed to create a product that improves upon natural cedar. Foundry is easier to install, lower maintenance, less expensive, and provides a natural shake or shingle look. For more information on the Foundry product line, please visit foundrysiding.com.